Some things in the universe happen so slowly that they almost seem to be standing still. A mountain does not rise in a day. A moon does not drift away in a single night. A star does not spend its fuel like a flame in the wind. And a galaxy does not turn with any urgency that a human life could ever feel. The universe has its own pace. It is not the pace of footsteps, or clocks, or messages arriving on a screen. It is not the pace of traffic outside a window, or thoughts moving quickly at the end of a long day. Cosmic time is wider than that, softer than that. It moves through gravity, through cooling stone, through starlight, through the slow bending of orbits, and through distances so large that even light must travel patiently to cross them. Here on Earth, time often feels small. A morning becomes an afternoon. A season changes. A year passes. We measure our lives in calendars, birthdays, plans, and memories. But above us, and beneath us, and far beyond the edge of the sky, another kind of time is always unfolding. Earth is turning quietly beneath your body right now. The moon is drifting a little farther away. The continents are moving, almost too slowly to imagine. The sun is aging in the gentlest possible way, and the Milky Way is carrying our solar system around its center in an orbit so large that one single galactic year lasts hundreds of millions of Earth years. Nothing is truly still, and yet almost everything feels calm. That is the strange piece of the universe. It is always changing, but rarely in a hurry. It is always moving, but often so smoothly that motion becomes stillness. It is always becoming something else, but over spans of time so deep that change begins to feel like rest. Tonight, we are going to drift into that slower universe, not the universe of sudden events, bright headlines, or dramatic endings, but the quieter universe beneath them, the universe of patient forces, the universe of stone becoming sand, of dust becoming planets, of stars shining for billions of years, and of galaxies turning in the dark like enormous lanterns on a path too wide for any one lifetime to follow. There is nothing here to rush, only time, wide, ancient, and peaceful. Begin with the simplest motion of all, the one that is happening beneath you even now. Earth is turning. It turns so smoothly that we do not feel it. The floor seems steady, the ground seems still. Mountains do not appear to sweep through space. Oceans do not seem to spin. Cities do not feel as though they are being carried around the planet at tremendous speed. And yet, they are. At the equator, Earth's surface is moving at more than 1,000 miles per hour as the planet rotates once every day. But because everything around us is moving with it, the air, the sea, the clouds, the trees, the buildings, and our own bodies, the motion becomes invisible. This is one of the first soft paradoxes of cosmic time. Something can move very fast and still feel still. The sky above us appears to turn through the night. Stars rise in the east and drift westward. The moon crosses the darkness. The constellations slowly change their position, but most of that movement is Earth carrying us beneath the sky. The planet turns, and our horizon slides gently across the universe, revealing one part of space while hiding another. Every night is a rotation. Every sunrise is Earth turning you toward the sun. Every sunset is Earth turning you away again. The rhythm is so familiar that it almost disappears, and maybe that is why it feels peaceful. Earth does not need to announce its motion. It simply carries the oceans and forests, the sleeping cities and quiet valleys, the deserts and mountain ranges, through darkness and into light. And even this daily turning is only one layer of motion. Earth is also orbiting the sun. The moon is orbiting Earth. The sun is moving through the Milky Way. The galaxy is moving through the local group. And all of this motion is unfolding inside an expanding universe. Stillness, as we experience it, is not the absence of motion. It is motion shared so completely that the body no longer notices. A quiet room on Earth is not truly motionless. It is a small resting place on a turning world, circling a star, carried by a galaxy, through a much larger cosmic flow. And yet it is still restful, it is still safe, it is still quiet enough for the mind to soften. The universe does not need to stop moving in order for you to rest. Above Earth, the moon keeps another kind of time. It has watched over oceans, deserts, forests, and human beings for longer than any story can remember. Its phases have marked months. Its light has crossed the roofs of ancient homes, the surfaces of rivers, the faces of travelers, the snowfields of winter, and the windows of sleeping rooms. The moon seems familiar, almost close, but its relationship with Earth is changing. Very slowly, the moon is drifting away from us, only a little each year, a few centimeters, about the width of a small hand over a human lifetime. Too small to see when you look up tonight, too small to change the shape of the sky in any ordinary moment, but steady enough that across deep time, the difference becomes enormous. Long ago, the moon was closer. It would have appeared larger in Earth's sky. Tides would have been stronger. Earth's days would have been shorter. The gravitational relationship between Earth and Moon has been exchanging energy for billions of years. Earth's rotation has gradually slowed, and the Moon has gradually moved outward. Not suddenly, not dangerously, not as a dramatic departure, just a slow gravitational dance. A planet and its companion, shaping one another through time. When you look at the Moon, it may seem like a fixed ornament in the night, but it is not fixed. It is part of an ancient motion, a gentle outward drift that no one can hear, no one can feel, and yet science can measure with extraordinary care. This is one of the universe's quietest lessons. The smallest changes, repeated long enough, become history. A few centimeters each year becomes a different sky. A tiny slowing becomes a longer day. A subtle pull becomes the story of two worlds. And in the same way, beneath the moon's light, Earth's continents are moving too. They move so slowly that the idea almost feels imaginary. A continent appears immovable. It holds forests, cities, rivers, mountains, borders, and lives. It feels like the definition of stability. But continents are not fixed plates on a solid, silent world. They are pieces of crust moving over Earth's deeper interior, carried by processes powered by heat, gravity, and the long behavior of rock. They move at speeds similar to the growth of fingernails, a few centimeters per year, small enough to vanish inside a human day, small enough to seem like nothing. But over millions of years, this slow movement opens oceans, closes seas, raises mountains, changes climates, redirects life, and redraws the face of Earth. The Atlantic Ocean widens, the Pacific changes. India continues pressing into Asia. Africa moves slowly toward Europe. The map of the world is only a temporary shape, a single frame from a film that runs for hundreds of millions of years. If you could watch Earth in fast forward, the continents would not look fixed at all. They would drift, collide, separate, and gather. Supercontinents would fall and break apart. Coastlines would stretch and fold. Mountains would rise where land presses into land. Oceans would appear where continents pull away from one another. But in one lifetime, the motion is hidden. The ground feels still. The mountains feel permanent. The sea seems to hold its familiar edge. Earth allows us to live on a moving surface without feeling the motion directly. This is another form of cosmic kindness in a scientific sense. We are carried by immense processes, but our daily world remains stable enough for a breath, a home, a walk, a night of sleep. And the mountains themselves, so strong and silent, are also temporary. They rise slowly, they soften slowly, they become sand. A mountain range is not a finished object. It is a long conversation between uplift and erosion. Deep forces forces push rock upward, rain pulls it down, ice enters cracks and widens them. Rivers cut valleys, wind carries grains, glaciers grind stone into powder, gravity moves loose rock down slopes. Time takes the sharp edge of a peak and gradually rounds it into memory. A single raindrop does almost nothing. 1,000 raindrops barely change the shape, but millions of years of rain can help carve a valley. Millions of years of rivers can reveal layers of ancient rock. Millions of years of wind, water, and ice can turn the tallest places on Earth into sediment that travels to the sea. A grain of sand may once have been part of a mountain. A stone in a river may once have rested high in a cliff. A mineral in a beach may one day become part of another rock, buried, pressed, heated, lifted again. Earth is always recycling itself, not quickly, not neatly, but patiently. Rock becomes sediment, sediment becomes stone, stone rises, stone breaks down. The world reshapes itself with a softness that only becomes visible when time is allowed to expand. And this is why the slowest things in the universe can be so calming. They remind us that change is not always a storm. Sometimes change is a drop of water, a grain of dust, a river carrying minerals under moonlight, a continent moving quietly beneath forests, a mountain becoming sand without ever seeming to move at all. From Earth, the mind can drift outward, past the atmosphere, past the moon, toward Mars. Mars is familiar enough to feel like a neighbor, but distant enough to feel like a dream of another version of Earth. It has a day not very different from ours, only slightly longer, but its year is almost twice as long, because Mars orbits farther from the Sun. This means the seasons of Mars stretch more slowly than ours. A Martian winter lingers, a Martian spring takes its time. The sun is smaller in the Martian sky, the air is thin, dust rests over red plains, ancient highlands, dry channels, and immense volcanic landscapes. Olympus Mons rises higher than any mountain on Earth. Valles Marineris stretches like a vast scar across the planet, a canyon system so large that it belongs to a scale beyond ordinary geography. Mars is not simply a red dot, it is a world full of old surfaces and old questions. Its valleys and minerals suggest that liquid water once played a much larger role on the planet's surface. Scientists study evidence of ancient lakes, river systems, and changing atmospheric conditions. They ask how long Mars may have been warmer or wetter, how its climate shifted, and what happened to much of its early atmosphere. These questions are still scientific questions. They are not solved by imagination alone. They come from orbiters, landers, rovers, meteorites, laboratory studies, and models that improve over time. But in the calmest sense, Mars is a world of slow memory. A dry valley remembers water, a volcano remembers heat, a crater remembers impact, a polar cap remembers seasons, a landscape can be quiet, and still hold evidence of a very different past. Mars teaches that planets have biographies. They are not just places, they are histories. Their surfaces are records. Their atmospheres, or the absence of thick atmospheres, are part of longer stories written by gravity, sunlight, chemistry, impact, and internal heat. From Mars, mind can drift farther outward into the broad, dark spaces of the solar system, toward Jupiter. Jupiter turns quickly. Its day is less than 10 Earth hours. Its clouds race around a planet so large that more than 1,000 Earths could fit inside it by volume. It is a world of bands, storms, magnetism, moons, and enormous gravity. And yet, when seen from far away, Jupiter appears calm. Its stripes curve gently around it. Its moons move in regular patterns. Its great red spot, a vast storm system, has been observed for centuries, even though it has changed over time. Here, fast and slow exist together. Jupiter spins quickly, but its atmospheric features can endure across long spans of human history. Its moons orbit in repeated rhythms shaped by gravity. Io, Europa, Ganymede, and Callisto move around the giant planet like notes in a deep celestial pattern. Some of their orbits are locked in resonances, meaning their motions relate to one another in precise ratios. A moon goes around, another goes around, their gravity tugs. The pattern continues. Inside those patterns, worlds change. Io is shaped by tidal heating. Europa's icy shell may hide a deep subsurface ocean. Ganymede has its own magnetic field. Callisto preserves an ancient cratered surface. Around Jupiter, time becomes layered. A short day for the giant planet. Longer orbits for moons. Long-lived atmospheric structures. Ancient surfaces. Hidden internal processes. Gravity repeating its gentle mathematics again and again. The solar system is not a collection of isolated objects. It is a family of rhythms. Every planet has a day. Every moon has an orbit. Every ring particle has a path. Every comet has a return, or a long disappearance. And from Jupiter, the mind can soften towards Saturn. Saturn may be the most peaceful-looking planet in the solar system. A pale golden sphere surrounded by rings so delicate that they almost seem unreal. From Earth, Saturn through a telescope feels like a quiet miracle. It looks arranged, balanced, graceful. But the rings are not a solid halo. They are made of countless particles, mostly ice, with dust and rock mixed in. Each particle is orbiting Saturn. Each particle follows gravity. Together they form bands, gaps, waves, and structures shaped by moons and resonances. From far away, Saturn's rings seem perfectly still, but they are motion made beautiful. A pattern created by countless small paths, and a bright disk of orbiting fragments, each one travelling quickly, while the whole system appears serene. And even Saturn's rings may not be permanent. Scientists continue to study their origin, their age, and their evolution. Some ring material appears to fall gradually into Saturn's atmosphere over time. A process sometimes described as ring rain. It does not happen like a storm in the ordinary sense. It is slow, subtle, and planetary. The rings may be temporary on solar system timescales. Temporary, here, is a word that must be heard gently. Temporary may mean millions of years. Temporary may mean longer than human civilization has existed by a vast amount. A thing can be temporary and still outlast everything we know. A ring can shine for ages and still be only one chapter in the life of a planet. Saturn reminds us that beauty does not require forever. Something can be passing and still be profound. Something can be slowly fading and still be magnificent while it lasts. Beyond Saturn, sunlight grows softer. The solar system becomes wider, colder, and more spacious. Uranus moves in its distant orbit, pale blue-green, tilted dramatically compared with the other planets. Neptune glows deeper blue, farther still, travelling around the Sun in a year that lasts about 165 Earth years. 1 year on Neptune is longer than many human lives. One season can last more than 40 Earth years. Imagine winter not as a few months, but as a climate of decades. Imagine summer unfolding across a span longer than childhood, adulthood, and old age for many people. Neptune has weather, clouds, winds, and internal heat, but its orbit is slow and vast. The sun from Neptune is still bright, but much smaller. Daylight exists there, but it is distant daylight, thinned by billions of miles. Farther out, Pluto takes about 248 Earth years to complete one orbit around the Sun. A single Pluto year is longer than the time since many modern nations were formed. On a Pluto-like world, sunlight is not absent, but it is faint. The Sun becomes a brilliant star, rather than a warm disk in the sky. The landscape may be shaped by ices that behave in strange ways under such cold conditions. When New Horizons passed Pluto in 2015, it revealed complexity where many once imagined simplicity. Icy plains, mountains, possible signs of slow geological activity. Even far from the sun, worlds can have stories. Distance does not erase meaning. Cold does not mean nothing changes. The outer solar system is a library of slow orbits. Icy objects circle the sun in paths that may take centuries, thousands of years, or even longer. Some bodies spend most of their time in deep cold, far from sunlight, moving along arcs no human civilization has ever witnessed from beginning to end. A world with a 1,000-year orbit does not hurry. It brightens slowly as it approaches the sun, then fades again into distance. Its year is longer than empires, longer than languages in their modern forms, longer than the memory of most human histories. The solar system has calendars we cannot live long enough to read, and among these long travellers are comets. A comet may appear suddenly to us, a soft visitor in the night sky, with a glowing coma and a tail stretching away from the sun. But most of a comet's life is quiet. Many comets spend long periods far from the sun, frozen, dark and inactive. They carry ice, dust, rock and ancient material from the early solar system. When a comet comes closer to the sun, warmth begins to change it. Some ices turn directly into gas. Dust is released. A cloud forms around the nucleus. A tail appears, shaped by sunlight and the solar wind. The visible comet may last only weeks or months, but its orbit may last decades, centuries, thousands, or even millions of years. A comet's brightness is only a small moment in a much longer life. It is a slow traveler with a brief glow, a messenger from the comet. An icy memory of the solar system's early days, appearing for a little while, then returning to darkness. This too is part of the slow universe. Not everything shines all the time. Some things are visible only during a tiny fraction of their journey. Some stories spend most of their existence hidden, then open briefly to the light. And light itself, though it is the fastest thing we know in a vacuum, must still travel. Sunlight takes about 8 minutes to reach Earth. Moonlight is sunlight reflected from the moon, and that light takes a little more than a second to cross the distance from the moon to us. Light from the nearest stars takes years. Light from the far side of the Milky Way takes tens of thousands of years. Light from distant galaxies may take millions or billions of years. Even light must be patient when the universe is large enough. When you look at the night sky, you are not seeing one single present moment. You are seeing layers of time. The moon as it was a moment ago. The planets as they were minutes or hours ago. Stars as they were years ago. Galaxies as they were before humans existed. Before mammals evolved. Before Earth's continents took their present form. Sometimes before the sun and Earth were here at all. Depending on how far away the galaxy is, the universe arrives late. And yet it arrives. Every beam of starlight is a journey completed. Every faint galaxy in a telescope is an old message reaching a new observer. The sky is not only space, it is memory. And memory, in the universe, travels at the speed of light. From comets and planets, we drift into the birth of stars. Stars begin in clouds. Not small clouds like those in Earth's sky, but enormous cold regions of gas and dust, often called molecular clouds. These clouds can stretch across many light years. They may appear dark because dust blocks visible light from stars behind them. Inside them, gravity works slowly. The region becomes slightly denser, then denser still. Gas gathers, dust gathers. The cloud begins to contract under its own gravity. As material falls inward, it heats. A protostar forms. Around it, a disk of gas and dust may begin to rotate. Jets may flow outward along the poles. The system is young, hidden, and changing. This is not instantaneous. A star's birth can take hundreds of thousands to millions of years. Before there is starlight, there is darkness. Before there is fusion, there is gathering. Before a solar system exists, there is dust. This is one of the most Light often begins slowly. A star is not simply switched on, it emerges from long preparation. Gravity gathers material, pressure rises, temperature increases, and if the forming object becomes massive enough, hydrogen fusion begins in its core. A new star joins the galaxy. Around many young stars, disks of material may form planets. Tiny dust grains collide and stick. Clumps become larger bodies. Over time, planetesimals form. Some collide, merge, break apart, and gather again. Gravity becomes more important as bodies grow. Protoplanets take shape. The system clears, rearranges, and settles over immense spans. A planet is not placed in orbit as a finished world. It is assembled. Dust becomes stone. Stone becomes planetesimal. Planetesimal becomes protoplanet. Protoplanet becomes world. And even then, the world is not finished. Its interior cools, its crust forms, its atmosphere changes, its surface is shaped by impacts, volcanism, wind, water, ice, chemistry, and sometimes life. A planet is a process slowed into a sphere. Earth is still changing. Mars is still changing. The icy moons are still changing. Even the smallest asteroid carries evidence of processes that began before planets fully formed. The universe builds with patience. It does not need one moment to make a world. It uses many. Our sun formed from such a process about 4.6 billion years ago. It is now in the long, stable portion of its life, fusing hydrogen into helium in its core. That fusion releases energy, and that energy eventually emerges as light and heat, supporting the conditions that make Earth's surface what it is. The sun feels steady to us. It rises every morning, it sets every evening. It returns with such reliability that it becomes the background of life itself. But the sun is changing slowly. Its core composition changes as hydrogen becomes helium. Its brightness increases gradually over time. Its future is shaped by the balance between gravity pulling inward and pressure pushing outward. For billions of years, this balance held. The sun is not a flame like a candle. It is a sphere of plasma, powered by nuclear fusion. Its life is not measured in sparks, but in billions of years. And because it is stable for so long, Earth has had time. Time for oceans, time for chemistry, time for continents, time for life to begin, diversify, and become aware enough to look back at the star that lights its world. The slow life of a star makes other stories possible. This may be one of the most important slow things in the universe. A star's patience gives planets time to become interesting. Not all stars live as long as the sun. Massive stars burn brightly and use their fuel quickly. They may live for only millions of years, which is brief in cosmic terms, though still far longer than human history. Smaller stars live much longer. Red dwarfs, the most common stars in the Milky Way, are smaller and dimmer than the sun. They use their fuel very slowly. Some may continue shining for trillions of years. Trillions, a number so large that it becomes less like arithmetic and more like atmosphere. The universe is about 13.8 billion years old. That is ancient beyond ordinary thought, but a trillion years is more than 70 times that. Some red dwarfs may last for many trillions of years, far beyond the current age of the cosmos. In fact, the universe is not old enough for any red dwarf to have completed its full natural life cycle. The longest stellar stories have not finished their first great chapter. Imagine a small red star shining quietly in the dark, long after brighter stars have changed or faded. Its light is modest, its energy is carefully spent. It is not spectacular in the way a massive blue star is spectacular, but it endures. Red dwarfs are the slow embers of the galaxy. They may become some of the final steady lights in the very far future. Around some of them, planets orbit. Scientists study such systems carefully, especially because red dwarfs are so common. Some planets may orbit in Liquid water could exist, but red dwarf systems can also be complex. Some stars are active, especially when young. Close-in planets may be tidally locked. Atmospheres may face challenges from stellar radiation. So we do not turn possibility into certainty. We simply observe that these small stars may last for immense spans of time, giving the universe a kind of long afterglow. While massive stars live brightly and briefly, red dwarfs live quietly and deeply. The universe contains both the brief blaze and the long ember. Our sun will not last forever in its current form. In billions of years, it will change. Like other sun-like stars, it will eventually leave its stable in-sequence phase, expand into a red giant, shed its outer layers, and leave behind a dense stellar remnant called a white dwarf. A white dwarf is not a star like the sun is now. It no longer sustains hydrogen fusion in its core in the same way. It is the exposed remnant of a stellar core, very dense, very hot at first, and gradually cooling over time. White dwarfs cool slowly, extremely slowly. They radiate away leftover heat into space. They fade over timescales so long that the universe has not existed long enough for any white dwarf to cool completely into what scientists call a black dwarf. A black dwarf is a predicted future object. A white dwarf that has cooled so much it no longer emits significant heat or light, but none are expected to exist yet. The universe is too young. This is a beautiful scientific thought. There are objects that physics allows, but time has not yet produced. The universe has not had enough time to grow old enough for it. A black dwarf belongs to a future beyond the present age of stars, a future so far away that it sits beyond almost every familiar scale. White dwarfs are like stellar embers. The fire of fusion is gone, but heat remains. They cool with astonishing patience, and their cooling is not dramatic. It is not sudden. It is not a spectacle. It is one of the quietest endings in astrophysics. Light, slowly becoming less light. Warmth, slowly becoming less warmth. A former star becoming a colder memory of itself. Even endings in the universe can be slow. Even fading can take longer than the cosmos has yet lived. Some stars end in more extreme remnants, such as neutron stars. A neutron star is incredibly dense, formed from the collapsed core of a massive star after certain stellar deaths. Some neutron stars are observed as pulsars, beams of radiation sweeping across space as the star rotates. Pulsars can spin very quickly, some rotate many times each second, and yet, over long periods, they gradually lose energy and slow down. Here again, the universe combines speed and patience. A neutron star may spin rapidly, but its long-term change is gradual. It loses rotational energy. Its magnetic field may evolve. Its place in the galaxy changes over time. Even the most extreme objects are not outside deep time. They too age. They too change. They too become part of the universe's slow unfolding. And then there are black holes. Black holes are often described in dramatic ways, but they can also be understood calmly, as natural objects described by gravity and space-time. A black hole is a region where gravity is so strong that within the event horizon, nothing can escape outward, not even light. Some black holes form from massive stars. Supermassive black holes exist in the centers of many galaxies. They can grow by accreting matter or merging with other black holes. When material falls toward a black hole, it can form a hot accretion disk and release enormous energy before crossing the event horizon. But a black hole can also be quiet. If little material is falling in, it can sit in darkness, defined not by what it shines, but by the gravity around it. Theoretical physics predicts that black holes may slowly lose mass through a quantum process called Hawking radiation. For large astrophysical black holes, this process will be extraordinarily slow, far longer than the current age of the universe. timescales are too immense, but as a theoretical idea, it is one of the slowest futures physics can imagine, a black hole fading over a period so vast that stars themselves are temporary beside it. At this edge, science becomes almost meditative. There are processes so slow that no creature could watch them from beginning to end. They exist not in observation as a whole, but in equations, models, principles, and careful reasoning. The universe contains more time than experience can hold. And still, we can understand pieces of it. From stars and remnants, let the view widen to galaxies. A galaxy looks still when photographed. A spiral galaxy appears as a luminous shape, its arms curved in elegant patterns. An elliptical galaxy appears smooth and ancient. A cluster of galaxies looks like a gathering of soft lights in a deep field image. The galaxies are moving, they rotate. Stars orbit their centers, gas flows, dust gathers. New stars form in some regions. Old stars continue their long paths. The Milky Way itself is rotating, and our Sun is orbiting the galactic center. One full orbit of the Sun around the Milky Way takes roughly hundreds of millions of years. This is sometimes called a galactic year for a star, a year for a solar system, not a year of seasons, but a year of galactic motion. The Sun is moving very quickly through space, but the path around the Milky Way is so enormous that one orbit takes longer than the rise and fall of countless species. The last time the Sun was in the same general region of its orbit around the galaxy, Earth was a very different planet. Continents were arranged differently. Life was different. The future of mammals, birds, flowers, and humans was still unfolding across biological time. Human civilization is only a tiny fraction of a galactic year, a brief glow near the edge of one eternity. This does not make humanity meaningless. It gives our moment context. We live inside a galaxy that turns too slowly for us to see, but not too slowly for science to understand. A galaxy is like a clock whose hands are stars. Its face is dark matter, gas, dust, and gravity. Its tick is measured in millions of years. The Milky Way and Andromeda are moving toward a future gravitational interaction expected billions of years from now. This is sometimes described as a future collision, but a calmer word is interaction or merger, because galaxies are not solid objects. They are mostly space between stars. When galaxies meet, individual stars usually do not collide directly. Instead, gravity reshapes the systems over vast timescales. Spiral arms stretch, streams of stars form, gas clouds are disturbed, new star formation may increase in some regions. The galaxies pass through and around one another again and again until they eventually settle into a new, larger structure. If you could watch it in real time, it would seem almost frozen, but sped up across hundreds of millions of years, it would look like a slow dance of light, a gravitational transformation. The universe often creates new forms by rearranging old ones, not with haste, with gravity. From galaxies, the mind can drift even farther, into the expansion of the universe itself. On small scales, gravity holds things together. Earth holds the moon, the sun holds the planets, the Milky Way holds its stars. The local group of galaxies is bound by gravity, but on the larger scales, beyond bound systems, the universe is expanding. Distant galaxies, on average, move away from us as space itself stretches. The farther away many galaxies are, the more their light is stretched by cosmic expansion. This stretching shifts the light toward longer wavelengths, a phenomenon known as redshift. Redshift is not merely a color change. It is a record of the universe's growth. A photon leaves a distant galaxy. It travels for millions or billions of years. During that journey, space expands. The photon's wavelength stretches. By the time it arrives, it carries the history of that expansion. Light becomes a messenger from both place and time. It tells us not only where it came from, but what happened to space while it was travelling. The expansion of the universe is one of the largest slow processes science can describe. It does not affect ordinary objects in daily life. Your room does not expand. Your body does not expand. Earth does not expand away from the moon because of cosmic expansion. Local forces are far stronger at small scales, but across the great distances between galaxy clusters, expansion becomes the architecture of the cosmos. Space itself changes the journey of light. That thought is quiet and immense. The universe is not a fixed stage. The stage itself evolves, and every ancient beam of light crossing it is stretched by the history of that evolution. There are other slow clocks hidden closer to home, inside matter itself. Some atoms are unstable. Over time, they decay into other atoms or isotopes, releasing particles or energy. This process is called radioactive decay. It happens according to statistical rules and characteristic half-lives. Some half-lives are short, others are long. Some last millions or billions of years. Because decay rates are measurable, scientists can use certain isotopes to estimate the ages of rocks, meteorites, and planetary materials. A rock does not tick like a clock. It does not show hands or numbers. But inside it, atoms are changing, quietly, predictably, patiently. Matter itself remembers time. A meteorite in a museum may contain minerals from the early solar system. A crystal in an ancient rock may preserve the moment it formed. Lunar samples, meteorites, and earth rocks all carry time in their chemistry. This is one of the most elegant ideas science is. Time is not only measured by clocks we build, it is written into the transformation of atoms. A stone can be a calendar, a mineral can be a memory, a meteorite can be a message from before Earth's surface became the world we know. And in the same way, ice can be a memory. On Earth, glaciers move slowly. They appear solid, and they are solid, but under their own weight, they flow. They carve valleys, carry stones, grind rock, and shape landscapes. Their motion may be slow enough that a person standing nearby sees nothing, but over years, decades, centuries, and millennia, ice becomes a sculptor. Ice cores can preserve layers of snowfall, dust, volcanic ash, trap air, and chemical signatures. Scientists read those layers to learn about past climates. A glacier is not just frozen water, it is a moving archive. On other worlds, ice can behave in surprising ways too. On Pluto, nitrogen ice appears to flow in glacier-like patterns. On icy moons, water ice may shift and fracture. Materials that seem rigid in one environment may move slowly in another. Depending on temperature, pressure, and composition, the universe is full of slow materials. Ice that flows, rock that bends, metal that cools, dust that gathers, gas that collapses into stars. Nothing is as fixed as it first appears. Even constellations change. The stars in the night sky seem arranged into familiar patterns. Orion, Scorpius, Cassiopeia, the Big Dipper. These shapes feel ancient because they have guided human imagination for thousands of years. But stars move. Each star has its own motion through the galaxy. Over tens of thousands of years, the patterns shift. Over hundreds of thousands of years, familiar constellations become unfamiliar. The stars that appear grouped from Earth may actually be at very different distances, unrelated except by our point of view. A constellation is a human pattern drawn in a changing sky. It is beautiful, it is meaningful, but it is temporary. The sky our ancestors saw was nearly the same as ours, but not perfect. The sky of the distant future will be different. The figures we recognize will loosen, stretch, and dissolve into new arrangements. Even the night sky has a lifetime. Earth's axis changes too. It slowly wobbles in a motion called precession, completing a cycle in about 26,000 years. We Because of this, the star nearest the North Celestial Pole changes over long periods. Polaris is our pole star now, but it has not always been, and it will not be forever. Even North in the sky is temporary. A guide star for one chapter of human history, not for all time. There is something peaceful in this, if we let it be peaceful. The universe does not promise that every shape will remain the same. It offers beauty in motion. Patterns appear, guide us, and eventually become other patterns. Nothing has to be permanent to matter. Now let the mind drift back across all these slow things. Earth turning beneath the night. The moon moving outward by a tiny amount each year. Continents drifting across the globe. Mountains rising and becoming sand. Mars holding the memory of ancient water. Jupiter spinning beneath storms that can endure for centuries. Saturn's rings shining as a temporary but magnificent structure. Neptune taking 165 Earth years to complete one orbit. Pluto taking 248. Comets sleeping in darkness for thousands of years. Stars forming from clouds. Planets gathering from dust. The sun shining steadily across billions of years. Red dwarfs burning for trillions. White dwarfs cooling into futures the universe has not yet reached. Galaxies rotating across hundreds of millions of years. Galaxy mergers unfolding like slow dances. Space expanding, light stretching, atoms decaying, ice flowing, constellations changing. Everything is moving, everything is becoming. And yet the deeper we look, the calmer it feels, because the universe is not frantic, it is vast. Its most powerful changes often happen without urgency. Gravity does not rush, but it shapes galaxies. Water does not hurry, but it carves canyons. Fusion does not shout, but it lights stars. Expansion does not announce itself in a room, but it stretches light across the cosmos. Patience is not emptiness. In the universe, patience is creative. This is easy to forget in human life. We often measure importance by speed, how quickly something happens, how soon a result appears, how fast we answer, move, finish, arrive, decide. But the cosmos measures differently. A star can spend billions of years doing its most important work. A planet can take ages to cool, settle, and change. A canyon can be made by a river that simply keeps going. A galaxy can take hundreds of millions of years to make one turn and still be moving exactly as it should. The universe reminds us that slow does not mean weak. Slow can be enormous. Slow can be steady. Slow can be the way the deepest things are made. And perhaps this is why thinking about cosmic time can feel risky. It does not remove us from our lives. It places our lives inside a wider rhythm. The day may have felt busy. Thoughts may have moved quickly. But above all of that, Earth continued to turn. The moon continued its orbit. The sun continued shining. The stars continued their slow lives. The galaxy continued its long rotation. Nothing in the cosmos asked you to hurry. The universe carried you anyway. Imagine now that you are floating far above Earth, not in danger, not in motion you need to control, but simply resting in a quiet view. Below you, Earth turns slowly. Clouds curl over oceans. Night spreads across one side while morning brightens another. The moon glows nearby, continuing its long outward drift. Farther away, Mars moves through its longer year. Jupiter turns, striped and immense. Saturn's rings circle the planet particle by particle. Neptune follows its long path in distant blue light. Comets sleep in the dark beyond. The sun shines with steady warmth. The solar system travels around the Milky Way. The Milky Way turns. Galaxies drift. Light crosses the universe. All of it is happening now. While you breathe. While you rest. While the room is quiet. This moment is not separate from deep time. It is part of it. A small living moment on a small blue world, held inside the same physical story as moons, mountains, stars, galaxies, and ancient light. You do not need to understand every number. You do not need to hold every distance. You do not need to reach the far future. You can simply let the feeling of it widen around you. Time is larger than the clock. The universe is slower than the day, and rest is allowed inside motion. The moon does not stop drifting because no one is watching. The continents do not stop moving because the night is quiet. The sun does not stop shining because Earth has turned away for a few hours. The galaxy does not stop rotating because we cannot feel it. The universe continues with or without our attention. And for tonight, that can be a comfort. You are not responsible for keeping the stars in place. You are not responsible for turning the Earth. You are not responsible for the moon's orbit, or the sun's fusion, or the long path of the Milky Way through space. You are simply here, a small living part of a vast, patient universe, breathing, listening, letting the day loosen. In the far future, small red stars may still glow long after brighter stars have faded. White dwarfs may continue cooling in the dark. Black dwarfs may eventually exist if the universe lasts long enough and the models remain right. Black holes may change over timescales so enormous they feel almost beyond imagination. Galaxies may become quieter. Space may continue expanding. But that future is not here tonight. Tonight, the stars are still above us. The sun will return with morning. The moon may shine through clouds. Earth will complete another rotation. And the slowest things in the universe will continue gently, without hurry. Let that be enough. Let the mind move like a planet in orbit. Let the body rest like a bird held by gravity. Let each breath become slower, softer, easier. A breath in, a breath out. A small rhythm inside a larger rhythm. Earth turns, the moon drifts, the continents move, the mountains soften, the rivers carry stone, the planets orbit, the comets return or vanish into long dark paths. The stars burn, the red dwarfs wait through trillions of years, the white dwarfs cool, the galaxies turn, the light travels, the universe expands, and you are here, resting inside orbit, safe on Earth, held by gravity, covered by night, beneath a sky filled with slow and ancient things. Nothing needs to hurry. Nothing needs to be finished. The cosmos has time. And tonight, so do you.